for two-dimensional drafting practices using AutoCAD. Okay, let's start new. AutoCAD ISO drawing. Okay, let's set the units, DD units to set the units. Precision, let's keep it 1 decimal point, and millimeter already is there. Okay, decimal degrees precision 0. Okay, set the limits so that the visible area will be the first limit, let it be 0 0. A second limit, it's already there, let's keep it 420 by 360 something. Within that region we can generate that cutter and sleeve drawing. Okay. Let's start the line. The line, let's start from 20, 20. Okay, somewhere like this. At 120, at 190 length, at an angle of 0 degrees, it will become horizontal. And then 65 mm at an angle of 90 degrees. And again 190 mm length at an angle of 180 degrees. It will go back and see, close that rectangle. Now let us see zoom and all. Zoom all. Okay, it's coming like that only. This is what our sleeve basic structure. Let's draw a center line and select the midpoint. The triangle symbol shows the midpoint. Okay. Let us offset. Pressing O, offset this line at a distance of 16 mm up and bottom. Okay. 16 mm goes up, 16 mm goes down. This is for the internal diameter. Okay, now sleeve is ready. Let's create a cutter. The cutter pin, let's start with the line. Okay, line, you pick up any point anywhere. Okay, let's give 27 mm at 180 degrees so that it will come to the left side, and again 90 mm at an angle of 90 degrees. Okay, and 30 mm at an angle of 0. Okay, and close it. Okay, this is our cutter pin. Let's move this cutter pin. Move. Okay, move this cutter pin. After clicking M and enter, select the object, enter, and select the midpoint to this end of this. Again, let's move this. Let's move this object. Select this, shift by pressing shift, select this object, and once select object completed, you pick up the center of this at 32 mm. Okay, let's give at 32 mm at an angle of 0 already there. Okay, at 32 mm at an angle of 0 degrees. Okay, now it's moved. Let's offset these sides so that it can show the assembled view. Okay, offset by 2 mm instead of 16 mm. Select this side and keep it here, and select this side and keep it there. Okay, then let's trim it. Trim, TR, trim it. Select this trimming edge, this trimming edge, this trimming edge, this we don't need, this trimming edge, this trimming edge. Then let us select the edges we are going to trim it. This one we don't need. This one we don't need. This one we don't need. This one let's trim it. This one let's trim it. This looks fine. Okay. Now let's create the rod. To create the rod, let's start with the line. This line, it goes 30 mm, okay, at 0 degree. Okay, and then 25 mm at 90 degrees. Again, it goes back 30 mm at an angle of 180 degrees. Then close it. See. Okay, this is for. Okay. The next thing is, let's create one more rectangle. Draw a line from this. It goes. This dia we are given 32. Okay, it should enter 32, right? So 32 at it can go at 65. Okay, escape, draw a line at select any point at 65 mm 0 degrees. Okay, and then and then up by 32 mm at 90 degrees. Okay, again 65 mm the reverse direction 180 degrees, and C for closing it. Okay, let's see how it works. Then move the small rectangle. Okay, add midpoint to the midpoint. This is what our rod. Okay, now let's move this. Let's give a chamfer. CH. Okay, A. CHA for chamfer. The chamfer edge. Now let's give angle. For that, the first length is 2 mm and the angle is 45 degrees. Okay, now select this horizontal line and the vertical line. Again enter it, again enter it and choose A. Already given 2 mm length and 45 degrees. Okay, let's select horizontal line and the vertical line. This is done. Let's draw one more line from this to this end. Okay, now let's move this. Move it by picking up this midpoint, and then somewhere I think this length should be higher. We have chosen a wrong length. Then we have to create the rod again. This is how we are going to practice, right? The rod length as per the drawing is 45 degrees. Okay, length is rod length is 107 mm. Okay, that's right. We delete this, delete this, delete this, delete this. Let's create one more line at 107 at 0 degrees. Okay, at 32 90 degrees. Okay, and then 107 at 180 degrees. Okay, C for closing it. Now move this subject to this midpoint, Okay, let's give chamfer. Let's give chamfer. Okay, and chamfer, let's give it angle, and 2 already we have given chamfer length, and chamfer angle 45 we have already given in this practice section. Then horizontal line, vertical line. Okay, enter. Then again angle. Okay, enter 45, enter, then horizontal line, vertical line. Okay. And then draw a line from this end point to this end point. Keep it like that. Now it looks professional. Let's move this. M for moving an object in AutoCAD. After selecting the object, enter and pick up that midpoint for base point and take it to midpoint of this horizontal line. Okay, now we don't need this, or otherwise we can convert this line type to this line type by layer. Okay, let's convert this line to center. Load. Okay. Let's apply this center to this. Okay, now it looks okay. Then let's mirror it. Mirror this part. Mirror mi, mirror. Okay, mirror this. Now select object. By pressing shift key we can select one by one all. Okay, selected. Let's select all these rod features and enter. Now to mirror it, enter. Okay, now the mirror has come. Again let us mirror it. Now select the object cotter pin and its entry point, whole visibility. Enter object selector. Now again you select this as a plane, enter it. Now that's it, we got it. Now what's the final stuff we have to do? We have to hatch it. Before that, let's trim something which we don't need. Okay, the trim edges, everything else will be there except very few stuffs needs to be trimmed. Okay, let's trim it. For trimming objects, let's select these two and these two, and trim this edge and trim this edge. Okay, that's it. This one we can extend it. So that it will look nice. Okay, now the cotter pin is ready. To give the hatching pattern, let's create one more stuff like spline, so that it will create a boundary for the hatching. It will look similar to our drawing exercise. Okay, enter it. Again one more stuff in this region, spline in this region. Okay, it will create a boundary for the hatching. Enter. And then one more spline here. Okay, enter. And one more spline. Okay, one more spline. No, this plane. Okay, here one more plane. One more spline here. One more spline here, so that the hatching will look nice. This plane has to go somewhere to, okay, here it's a bit. Let's see whether it's created a close boundary or not when we are doing a hatch pattern. Okay, let's select that hatch. Okay, in that ASME 131 is having 45 degrees angle. No problem. The scale, let us put it some 20 and pick up this region. Okay, set boundary, hatch internal point. The boundary is not created properly, it seems. This is this one. Okay, let's keep it. Find them. Oh, it's too heavy. Keep it one then. Okay, enter. Okay, this one also, this one also, this one. These are all the sectional view of sleeves. Okay, it's all in the one sided angle. Now sectional view of the rod should happen in other way around. Let's take it 90 degree angle. Okay, let's keep it and now enter and escape. Again, let's select the hatch. Now this time let's keep it 0 then. Okay, let's keep it 1 as it is. This is in opposite direction. Okay, this is for our rod. Now we have done the sleeve 2D drafting using AutoCAD for creating the sectional front view of sleeve and cutter joint. This is what the sectional front view of sleeve and cutter joint. And now let us give some fillets. Fillet, the radius are 3 mm in this region between these two edges, and let's give multiple, enter, so that we can give all 4 sides. Okay, this one, okay, this one, okay. Now it's okay, done. Okay, enter. Let's start giving dimensions. Let's see how it works. Before that, let's set the dim style. Dim STY stem style. Let's edit this, modify this, and see the primary units should be decimal places, 1 places. Okay, rest all in this. Okay, lines. Let's give everything looks nice. Let's see. Okay, dimension, linear dimension from this. Okay, this end point to this end point is 118 mm, but it should be by layer. Let's delete this. Let's give it by layer. Okay, 190 mm. And what else? And between these two, let's give what's the dimension between this again, dimension, linear dimension for intersection point of a node. Okay, this end it's 32. Okay, and then from edge end of the shaft edge to this end point is 42. Okay, and then from the same point, okay, to the end of the rod is 65. Okay, and then this dimension we can create an arc, but let us see. This dimension is 27, 27, and this dimension is 30. Okay, 30 mm, and this sleeve, this height, okay, from this point to this cutter pin height is 90 mm, okay, and the sleeve diameter is sleeve end point, okay, end point to end point 65 dia, okay. Okay, another diameter is this shaft dia end of this to this one is 25 dia, and then this shaft outer dia here to here is 32. Okay, now enter this should have a diameter symbol, right? This to have symbol, insert a symbol, diameter, and again the same way this should have a symbol, diameter, enter, and this to have a symbol, diameter, percentage C. Now this drawing completed, and before that we missed one feature, that is arc. Now we are going to give it unnecessarily at the 4 places. Okay, arc, from this to create end point, this end point, okay. Now give radius, the upper side is 30 mm. Oh no, and do it arc, E for arc, select this intersection point, this, sorry, arc, center point as the start point as this, and then give end point, for end point enter E, click this and give radius, for radius enter R, give the radius 30 mm, okay. In the same way, let us see here also, arc, start point here, for end point enter E and select that end point and give radius enter R and enter the radius 30 mm. Okay, now it looks nice. And in the same way, let's create one more arc and select the start point and enter E for end point, give that end point. Now select radius, to enter radius enter R, to give radius enter R. Now this side is 27, okay. And one more arc, start point, and to pick up the end point enter E, okay. End point has come, to give radius to this arc enter R first, and then give that length, arc length 27 mm, arc radius 27 mm. Now this is what our cutter and sleeve joint sectional front view we have completed. Okay, the drawing.